Good morning, friends. Welcome. Today we are going to discuss about some common field complaints on transformers and how we can contain them at the manufacturing stage itself. Here we go. Before going further into the discussion, we want to introduce ourselves. Like we 3SI EcoPower, we the directors got tremendous experience in this field of transformers. Like we worked in India, Middle East, Far East, Southeast, then the UK and the Europe. So we got all the working knowledge, and our design transformers are right from Japan, Australia to the Americas. Like we did very much, we got a lot of what you call experience in this field. And we, the directors, we are friends. Like we came together, we thought, okay, why can't we start on our own? So with that in mind, we just scouted for some industrial land and we zeroed in near Tada, AP. That is a government estate, industrial estate. The idea was like it should be strategically located near a seaport and a city. So Chennai is the nearest city, and we got Chennai port and Nellore port, Krishnapatnam. So that was the idea in zeroing into Tada. Then we started within 1.5 years of construction. We started commercial production in the year 2019, and we got very good customers. Some like the DX and Singapore. They're setting up a plant in Hyderabad, and yes, we are supplying transformers to them. We can manufacture transformers up to 16 MB of that 6 kV class. We are very well conversant with Minden oil or esters, silicon oil, Midel. So we can make all those transformers. And we do make amorphous core transformers which are very much energy efficient. And the tri-type transformers, we import coils and we assemble it at our factory. In fact, we supply to many shopping malls in and around Chennai with the added switchgear and making them as a package substations. And we do make special transformers like earthing transformers, rectifiers, high impedance transformers, etc. Even spot connected for railways we make. Then even open delta transformers for any specific design requirements we make. We make substations, and the hallmark is like we make compact in the sense really compact area wise. You know, the cost of the land is so high nowadays, so we are very good in designing a compact substation in two sets. And of course we make transformers for the renewable energy sources like windmill and solar. We are quality committed company. When I say quality committed, it's not like every other company where they just say for the sake of quality. No, in the true sense, we are committed to quality. Like how all the three top are quality oriented, and the same thing will percolate down to the bottommost level of the organization. And we are ISO certified. All the raw materials can be traced. Within no time, we have done CPRA testing of transformers, IS 1180 compliant, and more in the subsequent slides. A quick run through our quality systems. Like our quality documentation is something unique, like you cannot find it anywhere else. We can trace back right from uh, the time it has been logged in as a work order, all the raw materials that are going into the transformer trace back to the manufacturer's batch number and their serial numbers for the components, and our internal um, production physical dimensions, technical parameters, checks at each stage, then any reworks if at all done on those transformers, and the final testing, the dispatch, the outgoing checks, everything is captured and monitored. And the money we are spending, the time and the money we are spending with the quality checks, we don't see that as an additional burden to the cost of the transformer, but it pays back in giving a better quality product and doing better service if at all at site works demand to the customers. And the more we do on these things, it helps our R&D. And in fact, we always try to reduce the cost of the transformers without without diluting the quality. And ultimately, it is like a win-win situation for us. Like we always think the customers should get satisfied. At the same time, we should not lose any orders or save money. The technical edge we got on other suppliers is like we all three directors have a combined experience of 6 decades, that is 60 years. And all these things like in one side is like how to approach a customer, how to understand his requirements, how to deliver his requirements, how to satisfy all the needs of the customers with respect to the product. And at the factory side, what value addition we can give to the customers, like the customers may not specify the welding of the, for example, the welding of the stiffness. We got some R&D on that. And the paint system, many customers don't specify the paints, but we stick to certain paint systems. Otherwise, we go according to the climatic conditions where the transformer is supposed to be installed. Then the hardware, why to go for high tensile, why not SS? If at all SS is required, what precautions we have to go, or the clamping structure inside the core and coil assembly, like, and the number of hardware to be used, the tie rods, the calculations, all these things. Like we got a lot of case studies and we evolved a design model. Ultimately, it is to the benefit of the customer. So that is the technical advantage we can provide to all our customers. And after the brief introduction, now let us go into the topic of this session, that is the most common side problems and how we can contain during the manufacturing stage itself. One of the most common side problems or the transform problems is like rusted tanks or faded paint. Uh, you might have seen many tanks around just many transformers around the street corners where the tanks got rusted or faded. These things are a common problem across all the transformers. Uh, a faded tank or a rusted tank, they will downgrade the look of the site. So we can contain these problems during the manufacturing stage itself. Many customers, they don't specify what paint they need or the final DFT or any of those things. So in general, if the customer is not specifying any better paint system, we follow minimum of C4H as per ISO 12944 part 6. The basic thing is like we sandblast all the tanks and we apply epoxy paint system, primer, intermediate and finish, all complying to the C4H paint system. Now if customer is specifying, as I said, a better than this paint system, we follow that. So in other words, we don't take advantage of customers' ignorance on painting. We follow certain principles where we feel that it's not the customer's money, it's the respect of the supplier that goes. So we give a better quality painting system to all our transformers. And one more case study. What we have done over a period of time is like we go for all the external fasteners are as hot dip galvanized or dichromated, because this is the area where the rust starts catching up. So these things will delay the process of rusting. Now why we are going for 8.8 grades high tensile steel is some other case study, and we'll deal with that in next session. Along with the rusted tanks, we very often see our transfer tanks with oil leaks. This is again a very common problem for all the oil filled transformers. Now how we can contain these things at our factory, like what we do at 3SA EcoPower is like at the factory, at the tank fabrication stage itself, again we buy tanks from our own subsidiary company, United Engineering Works. So what we do is like we ensure 100% leak tests during fabrication of the tanks, and everything is properly documented, like all the reworks, number of leaks during fabrication, how it is contained, how much duration is the leak test applied, pressure applied during the leak test. All these things are noted, and all the fabricated tanks are 100% subject to the only after passing those tests, the tanks are fabricated further, like the painting or anything. And once we receive at the factory, what we do is like during the process of transformer, making a transformer, all the gaskets what we use are single piece gaskets, like there are no joints. Now most commonly again people will buy gaskets in rolls, they will do dovetail joint or butt joints, and they bolt. Now what happens if there are joints? Once the pressure is applied, there is every chance that the joints may get cracked up. So even if you're spending a little bit more money in purchasing single piece gasket like a rectangular gasket for cable boxes, or a single piece gasket for calls relay, flanges, cable boxes, bushing, pockets, and all these things like that. So this gives a good appearance to the transformer and avoid all the leaks. That's one important thing which we are doing. Then all fasteners, again 8.8 grade, as I said, they are properly tightened with the torque wrench and cross-checked. So once we do all these things, like even during fabrication of the transformers, we do the stud welding for all the pockets and bushings, radiators, everything. There are no bolts, like there are no holes on the tank where you are putting your to mount radiators or anything. It's all studs. So the less number of holes in the tank, the less chances of oil leak. So we follow all these basic things while fabrication of the tank, and while manufacturing, as I said, single piece gaskets, then proper torque tightening of all the fasteners, and once fully assembled transformer, it's a routine test for us to subject the transformer, a fully assembled transformer, with what you call pressure test. We do subject each and every transformer for minimum of 8 hours as per the relevant standards, maybe CBAP or IS 1180 or any other standard to which the transformer is being made. This is a routine test for us. Even the customer don't specify this, but we do all the transformers fully assembled and subject to the pressure test. Once we have successfully done these things, then the transformers are eligible for a dispatch with all other conditions satisfied. As far as pressure test is done, leak test at the fabrication stage, then various what do you call uh, points we are adding, like the gaskets or a torque wrench or a use of torque wrench or any of those things, and finally doing this pressure test for on a fully filled transformer. This ensures that there are no leaks at the site, and we have supplied so many transformers as of now, touch wood, there are no field complaints, at least on transformer leaks. Recently I was with a client. He was doing his factory expansion, and I was talking to him on transformers. Like the gentleman was asking me, like during his initial days, like when he started his project few years back, he purchased a well-reputed make transformer, and it took few months to build up the load. During these few months, like he was paying more EB bill. He says, I purchased transformer from a reputed make. It was factory tested properly, and all the no load losses are fine, well within the guaranteed values. But in spite of that, I was paying more. I did not put any load. Why it happened to me? He was asking me. It was not his problem generally. It is the problem in many places. These things will happen because people tend to mix the core material or buy inferior core plates or mix different core plates to guarantee the losses or to attain the guaranteed losses. But we at 3S Power, we buy prime grade and we do not mix the cores. So these things like help us in giving not only a good no load losses of the transformer, but good uh, magnetizing current, slow magnetizing current of the transformers. And all the cores, like what we do is like we give the proper drawing, core cutting drawing to our suppliers. We make the drawing and we make them cut according to our drawing, not just giving the leg length and core leg centers, asking him to stack thickness and asking him to make on his own. No, we make the drawings and we send to our suppliers, and all those drawings are uh, based on step lab cut. That is what we do. And the final testing of the transformer at our factory, is done with the Yokogawa power and laser. So, and there are many stages, like we mentioned the stage-based testing of transformers and eliminate all these issues. Like whatever we guarantee, we stick to that with proper material, and it can be traced back. Few years back, when I was working, we offered our transformer for testing for inspection to our client. The client has sent a reputed third-party inspector to inspect the transformer at our works. During the process of inspection, he asked me in particular, like, see, your design transformer is having very less radiators, the same capacity, the same specification your client is purchasing from another manufacturer, and that gentleman or that manufacturer is giving more radiators. Are you cost saving in radiators? This was the question he posed to us, and I was shocked. And I explained to him, no, sir, it is not like that. Less radiators does not mean that we are giving less on radiators. We are giving more on copper and core. I will explain how. And this is how many side problems come arise, like small transformers of the same capacity or transformers of the same capacity. Some manufacturers give more radiators and say that this is good. Like, in fact, when the job is 100% loaded, then you will feel the excessive heat generated from the transformer. This is again a common problem at site. So how how we can eliminate this problem? We eliminate this problem, or we contain this problem by doing proper design, uh, and doing a load losses as per the guaranteed one first. That's first step. Second, positioning, calculating radiators by calculating the thermal head of the transformer and position of the radiators. We do these advanced calculations based on our experience, based on our case studies. We developed a good calculation system of the radiators. We just don't depend on the dissipation of the radiators as per our suppliers catalogs or anything. We got our own data, and based on that we place the radiators. And a high quality radiator with more fluids per section will dissipate more heat. And for the same transformer of same capacity, if we are giving less radiators, it is because of the suitability of the radiators. The radiators what we give comply or will are more than sufficient to dissipate the heat generated by the transformer or the losses generated by the transformer. We comply to the losses what we guarantee, and the radiators will be as per the design. And the idea of having more radiators means it's a good transformer is not correct, or it's incorrect. Transformers are silent devices, as we all know. They are not like the generators and motors making high levels of noise. So noiseless transformers is not possible or may not be possible. However, we comply to the noise levels as per the standards, and we guarantee them. Though many manufacturers guarantee the noise levels, they don't take or give any due care to contain the noises. Now, very often you might have observed humming noise for transformers while you are passing by. Sometimes the noise will be unbearable. These noises can be contained well within the limits. And how? The main reasons for generating noise is like magnetostriction of the cores. During magnetic induction of the cores, uh, magnetostriction effect is induced or comes into effect. Because of this magnetostriction effect, the noises generate. Now, it will be more because of low-grade CRGO steel or mix of CRGO steel, which I was mentioning in earlier slides, like to get the no-load losses, some suppliers mix cores. We don't do that. So unmixing, of course, proper CRGO, prime material, if we are using, this can be contained. And another reason is like not clamping the core and coil properly. If you are not doing that, the cores become slightly loose to generate more noise. And we contain that by proper clamping with wooden blocks, then using high tensile 8.8 grade steel. So once tightened, it will be tightened forever. And one important, again, a case study which I feel worth to mention here is like once you tighten the core and coil assembly in a transformer and lower it in the tank, it should be for a lifetime, the tightness. Now, if we are not doing it properly, It may be working fine now, but if you are supplying 100 transformers and are distributed over the network, and after 10 years, 15 years, if there is a slight loosening of these nuts because of the magnetostriction effect, vibrations caused, and because of this magnetostriction, these nuts may get loosened, and sometimes these nuts may fall onto the transformer core and coil assembly, and the transformer may fail. It is not very often, but still there is a chance of 1 in 1000. These things will eliminate by properly tightening with 8.8 weight steel. When we are using 8.8 weight steel, once tightened high tensile, it will be tightened. You cannot they cannot be just loosened like that. You have to use again a torque wrench to loosen them. But if you are using a normal 4.6 grade steel or anything lesser, they may come off because of the vibrations they are facing. So these things we take care, and we reduce or we make transformers as per the accepted noise levels, and we take due care that the life of the transformers will not get damaged because of any looseness in the fasteners over a period of time. With this, we will come to the end of this session, and we will come with many other site issues which can be contained or easily attended at site itself. We'll meet in our next session on these further things. Before concluding the session, I want to just mention about our social responsibility, our principles on them, like we advocate quality at reasonable pricing, and of course, we want the whole world to look at India as a global leader for manufacturing quality products, and we are committed to that with our installed policies, processes, and products. Thank you very much. And if you require any details or clarifications, you may write to us at the below mentioned email ID. And if you need any transformers, yes, we are there always to support you. Thank you very much. Have a good time.